Okay, I have this function that I want to find the intervals on which it's increasing, decreasing, and then I want to look at local and global extreme values, so in other words, max and min. The only thing that I noticed right away is it didn't give me intervals. However, I know that anything under a square root has to stay positive. So I'm going to kind of get my intervals right now. So if it has to stay positive, that means this must be greater than or equal to 0. I can solve for x, so I throw the 32 to the other side. And remember, when you divide by -1, you're actually flipping your inequality sign, so that becomes 32. And then finally I square root both sides and I get x, and when you square root you have to do the plus or minus. The square root of 32, well, I can break that down into 16 times 2, and so that will give me plus or minus 4 square roots of 2. So what that tells me is that's my interval. So I know to be sure and you can kind of see the plus or minus because you're squaring it. So I see that my interval is going to stay in between this plus or minus 4 square roots of 2. So some of these you have to be careful, even if they don't give you the interval, you just have to know, right, that you're not going to go outside those bounds because of a square root function. Alright, so all of that's kind of a side note to now actually work the problem. So if I want to know where it's increasing or decreasing, I don't know what I just clicked on, then I need to find the critical points. How do we find critical points? We find the derivative, we set it equal to 0, and we solve for x. Well, I can certainly see my function is going to be a product rule. So the derivative says take the derivative of x, which is 1, leave this piece alone, plus leave x alone, times the derivative of the other. Well, remember, anything that's a square root, the derivative is 1 over 2. Square roots leave everything the same inside, times the derivative of the inside. Well, the derivative of negative x squared will be negative 2x. That's why I strategically left that empty up top in the numerator. I can, of course, cancel the 2's. And so from here, I end up with square root of 32 minus x squared. Up top I have what, a minus x squared, and then on the bottom I have 32 minus x squared. Now this is what I'm setting equal to 0, and I'm solving for x. First thing I probably would do is get rid of the horrible fractions. In other words, I'd make one fraction. So what I'm going to do is I'm going to multiply every single term by the least common denominator, which is that whole square root thing. So I'm going to have the square root of 32 minus x squared times 0. This is this square root that's already there times my least common denominator. So I'm going to do this. That's an x, by the way. And then my last piece, I don't have to do anything with it because it already has my common denominator. 32 minus x squared. Alright, so from here I get, that's 0 of course, square root times a square root goes away. And then I still have this minus x squared, but now I can write all of this over this square root, which makes this really, really nice, right? Because when you solve for x now, we only care about the numerator. So let's collect those like terms. And this is what I'm solving for x. So I get negative 32 equals negative 2x squared. I get divide both sides by -2. I get 16 equals x squared. I do my square roots, so plus or minus 4 are my critical points. So from here is where we drew our number line, and we put in the critical points. And probably what I would do is remind myself way back up here, way right here, of my interval. So let's go ahead and put that on my number line. So the -4 square roots of 2, la 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 la. So this actually ends here at -4 square roots of 2 and at 4 square roots of 2. I mean, if you want to put that in the calculator and get an actual number, you could, right? So you know the actual value there. So these are my endpoints of my interval. From here, what I do is I'm going to actually see where the function is increasing, and then of course where it's decreasing. So I do that by picking values inside these intervals. So I don't know, I'd pick -5 because I actually plugged 4 square roots of 2 in the calculator, and that's -5.65. So I just know that's not too outside my interval. In here, of course, I'd plug in 0, and then in here I'd plug in 5. If I do that, I plug in to my derivative, because that tells me where it's increasing or decreasing. I plug in 0, and I plug in 5. And I probably would go back to the line, I know I'm jumping around, but I probably would go back to this, meaning -2x squared plus 32 over, this is the derivative format that I'm going to plug in down here. So when you see me plugging into the derivative, that's the one I'm going to use. So I have -2x, which is -5, I don't know why I put -2 in parentheses, squared plus 32, and then all of this divided by 32 minus, what do I have, -5 squared. And I do the same thing for each one of these. So I'm plugging in 0, I'm plugging in 5, and then 32 minus 0 squared and 32 minus 5 squared. So I mean, you should go through and put this stuff in your calculator, but as we've said before, we don't really care what the number is. All we care is if it's positive or negative. This is negative, this is positive, and this is negative. So that means it's decreasing in this interval. It hits 0, it increases, it hits 0, and then it decreases. Okay, so in other words, this is my negative interval, this is my positive interval, and my negative interval. So we can see already that this piece is going to be, a max, and this piece is going to be a min. Of course, this piece here, and notice what a really bad job I did with my picture. This piece here stops right there, right? So it doesn't go back up, didn't go back up there. Same thing here, this piece stops there. So I know that I'm going to have some global, in this case, that's going to be a global, of course, max. In this case, that's going to be a global, of course, min. But I also have these local as well, so I can say that, well, depending on if I'm looking at within a particular interval, this function's going to have a local minimum at the -4, and then also at this value right here, so that would be a local min, and this would be a local min. And then I also have a local max at this piece, and then at that piece, well, I keep missing my dot, at that piece right there. But then these are also global. So in other words, I know you're so confused. So let's kind of write this out so you can see. The first thing I want to write out is where is it decreasing? Well, from this stuff right here, that's where it's decreasing. So this function is decreasing on the interval -4 square roots of 2 up to that critical point, which is -4, and then to the next critical point, which is 4, and then that other n value. And then, of course, it's increasing in the middle there. And I'm looking at where it's increasing, and they use square brackets in my math lab, but you know at the actual points, the critical points, it's constant. But so it's increasing on this interval. And then finally, if we list our local max and local mins, so local max, local min, as if I can kind of still see my picture, how horribly ugly it is. It's going to have a local min at x equals -4. That one's pretty clear to see, right? But then it also has a local min at the x equals 4 square roots of 2. And so my local max would be that one way up chair at 4, and then a local max right there at x equals -4 square roots of 2. And then finally the absolute for the entire function would be the highest point, the lowest point. So absolute max or global, absolute min. This absolute max would be at x equals 4, and my absolute min would be at x equals -4. So probably the biggest thing in this one was to realize you did have an interval, even though it didn't give it to you, as far as those square roots. Hopefully that video didn't confuse you too much.